All right, welcome to 4.6, inverse trig functions. So, there's some little bit of background I'm going to discuss that will hopefully help make this more sense. So, I drew here basic sine and cosine functions, right? Uh, and we're finding inverse of functions, right? You just flip the x and the y values, right? Uh, so, if I'm doing that with these functions, though, uh, there are going to be multiple y values that are the same throughout, right? So that's going to make things hard, right? So if I'm trying to find the inverse sine of, let's say, 1, one's here and one's here. Remember, this is inverse, so your input's your y now. So there's multiple ways forever that you're going to get a single value anywhere in between -1 and 1, right? Uh, So what we do with inverse trig, with regards to sine, your answers are only going to be in between here and here. That way, every y value that could possibly happen with a trig function is represented. Uh, so we can say the domain of the sine function is between -1 and 1, and the range, those values there, if you look at your unit circle and past graphs, will be between -pi/2 and pi/2. Now for the cosine graph, it's going to hit every possible y value between those two values. So domain, -1 to 1 again. But this time for cosine, your range is 0 to pi, including those values. So we're at a couple quick examples. So if you see arc's just another way of writing inverse sine or inverse whatever trig function. So arc sine of √3/2. Look at your unit circle, okay? Keep in mind, if you remember this graph, you're looking between -pi/2 and pi/2. So you're looking at the right two quadrants, okay? And since we're dealing with sine, you're finding which y value is √3/2. So where do you see a y value √3/2 on one of the two right quadrants? You see it at pi/3. So your answer to that one is pi/3. Next one, inverse sine of -2 pi. Once again, you should notice red flag right now. And that is that -2 pi is not in between or including -1 and 1. So this does not exist. Arc sine of -1. So once again, right side. You see -1 anywhere for a y value? Yes, you do. That's at -pi/2. No, you cannot write the answer to be 3 pi/2. Your answers must be for inverse sine be in between -pi/2 and pi/2 for all of them. Okay. Let's try some cosine ones. So once again. So if you look at the graph above, what do we say we're working between? 0 and pi. Okay. So 0 and pi, you're going to look in between those two radians. Now, where do you see -1/2? Now, it's cosine, so you're looking at your x values. So -1/2, where do you see that as far as your x values go? You see that at 2 pi/3. So that is your answer. Now, how about -√3/2? Where do you see that? You see that at 5 pi/6. Right? The x value at 5 pi/6 is -√3/2. So that would be your answer. We will also see some function like these where they're a function within a function. So you work on the insides first and work your way back. So for the one on the far left here, so we have inverse cosine of cosine of 3 pi/4. So what's cosine of 3 pi/4? That would be -√2/2. And inverse cosine -√2/2 is 3 pi/4. Will it always work out that way? No. Well, in this case it does because these are both the same trig function, just one's inverse of each other, and it's between 0 and pi for cosine. As opposed to over here in this next one, where since it's sine, it'd need to be between negative pi over 2 and pi over 2. So when we go to solve this, sine of 2 pi over 3 is root 3 over 2. And the inverse sine of root 3 over 2, what would that be? That would actually be pi over 2. Excuse me, pi over 3 rather. So pi over 3 is root 3 over 2. And also remember, it has to be between negative pi over 2 and pi over 2. Next, we have two different trig functions. That's going to be interesting. So what's sine of pi over 3? Sine of pi over 3 is root 3 over 2. And where is the inverse cosine? Where is that root 3 over 2? It's at pi over 6. Remember, the answer has to be between 0 and pi. Finally, we have a little bit of a goofy one over here. We have sine of arctan of 5 over 13. And really, I'm going to change this problem to make it look nicer. So it's going to be 5 over 12. Okay? So arctan of 5 over 12. So what does that mean for us? Well, if we were to draw this, 5 over 12. So remember, tangents opposites over adjacent. So opposite's going to be 5, adjacent's going to be 12. And if you use Pythagorean theorem, you're going to find that to be 13. Or if you know that, remember, your 5, 12, 13 is one of your right triangles, that works as well. So sine, what's sine? Opposite over hypotenuse. So your answer would just be 5 over 13. Now we're going to do tangent, then we'll call it. So for tangent, domain. What's your domain for tangent? Well, the domain's going to be all real numbers, right? Because remember the graph of the original tan function, it does one of these, right? Right? A bunch of times throughout. So it can, if that's going to, that's your range for your original, then that's going to be your domain for your inverse. And the range, if you remember the graph, one period was between negative pi over 2 and pi over 2. So that's going to be your range here. So all your answers will be in between here. Okay, so that means once again we're looking at the right side of your unit circle when looking at your answers. And remember, tangent's y or x. So where is y over x equal to these values in the inside? That's what you need to be thinking about. So the first one's a little bit easy because it's inverse tan of -1. Now, where is y over x equal to -1? So that means that your y and x value is going to be the same, just opposite of each other. Well, that's at negative pi over 4. Okay? If you look at negative pi over 4, you get what? Root 2 over 2 common negative root 2 over 2. If you divide those up, that's going to get you -1. Right? So at negative pi over 4 is where your answer is going to be. And arctan of negative root 3 over 3. So, once again, y over x. Where is y over x going to get you negative root 3 over 3? Well, that means that our root 3 over 2 needs to be in denominator, wherever that is, okay? And if root 3 over 2 is in your denominator, that means it's your x value. So where is that? That would be at negative pi over 6. You're going backwards to negative pi over 6. I appreciate watching. No, we will not be doing the other 3 trig function inverses, just these 3. So, yay. Appreciate you watching. We'll see you in class. Bye-bye now.